All right, so same idea. We can look at question 3. We can find the domain. So we know that the square root of x always has to be non-negative, aka x always has to be 0 or greater, which means that the domain is 0 to infinity. In this case, though, we can equal 0. All right, so then now let's take the derivative, right? So dy dx, right? So remember, if we're taking the derivative of 3 raised to the u, it's going to be the natural log of the base 3. We're going to have 3 to the u, and we're going to have u prime also in there. All right, so then dy dx is going to be natural log of 3, right, our base. We're going to take the same function, right, so we're going to have 3 raised to the x, and then we have to take the derivative of the square root of x, which is going to be 1 over 2 radical x. All right, so here's going to be our function, right? We can say that we have natural log of 3 over 2, right? That's our constant. 3 raised to the x over the root of x. All right, so then now when we look at this, if we're trying to find critical values, the numerator, natural log of 3 times 3 to the x, this is never 0. Right, 3 to the x is always an increasing exponential function, and our denominator will be 0 when x is equal to 0. So that gives us a potential critical value. Now, the issue here is that we can't do anything to the left of 0, right? So we're starting off with some issue in our function. Right, so when we look at what this means for us, right now we can have 0. Right, so if we look at the first derivative, if I plug in anything that's a positive number, natural log of 3 is positive, 2 is positive, 3 to a positive number is positive, square root of a positive number is positive. So anything that I plug in here, I'm going to get a positive coefficient. 3 to the x is positive, square root of x is positive. So this means that our first derivative is positive, and thus our function is increasing. If we take the second derivative is going to require a quotient rule. So we have d dx squared. So I'm going to pull this natural log of 3 over 2 kind of out and not even worry about that for a second. And then I'm just going to take the derivative of 3 over x squared of x. All right, so we're going to get the bottom times the derivative of the top. Natural log of 3 to the x minus the top times the derivative of the bottom, 1 over 2 rad x, over the bottom squared, so radical x squared, right? That's just going to give it 0 again. All right, so let's see what we can do in terms of cleaning this thing up. There's a 3 to the x that appears in both. And so I can pull 3 to the x out front. I have natural log of 3 times the square root of x minus 1 over 2 radical x, this whole thing over x. And it's over this natural log of 3 over 2 out front. Oh, excuse me. So then let's see, is there any place where this numerator is equal to 0? So we know that 3 to the x is never 0. We know that x is only 0 when x is 0, which we already kind of talked about. We haven't, it is the left endpoint of our domain. All right, so let's see, natural log of 3 radical x minus 1 over 2 radical x. Is this thing ever equal to 0? I mean, it's undefined again when x is equal to 0, but that doesn't really matter. I'm going to multiply everything through by the square root of x, right? So everything here by rad x. So I have natural log of 3 x minus 1 over 2, right? Those square root of x's cancel, equals 0. So then I can bring this over. I can solve for x. So I can get x equals 1/2 natural log of 3. So what does that equal out? That's a small number. So 1 over 2 natural log of 3 would be 1 divided by ln of natural log of 3. Oops, natural log of 3. And that thing cut in half. To that, boom. So like 0.445, right? So that's where we're going to have a potential inflection point. And so here we are, 1 over 2 natural log of 3. So if I plugged in something smaller than that, right? If I plugged in, say 0.25, if I plugged in a quarter, into our second derivative. Let's see what we get. So I know that 3, if I just take this thing again. Right, so 3 to 1/4 is positive. Natural log of 3 times the square root of a quarter is natural log of 3 over 2, right? Square root of a quarter is 1/2 minus 1 over 2 times 1/2. 2 times 1/2 is going to be just 1/2. I mean, just 1. So this is minus 1 all over the square root of 1/4, which is positive, right? So I get the natural log of 3 minus 1, which we just saw is a negative number. Oh, wait, no, we didn't. No, we didn't. Naturally, we saw 2 over natural log of 3. It's going to be the reciprocal. It's going to be bigger than 1. So if we did natural log of 3 over 2, oh, wait, no, it's still be less than 1. Ha, ha, ha. So if we did the natural log of 3 over 2, we're going to get 0.54. 0.54 minus 1 is going to be a negative number. So that means that our second derivative is negative. So this is f double prime. And if we plug in something greater, it's going to be positive, right? So as x got really, 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 really big, this natural log times a really big number is going to get big. 1 over half times a really big number is going to get really, really small. So you have a really big number minus a really small number, right? So it's going to stay bigger than 1. So this means that we have an inflection point at x equals 1 over 2 natural log of 3. Concave down from 0 until 1 over 2 natural log of 3. Concave up from 1 over 2 natural log of 3 to infinity.